Hey, welcome back to our third video for notes number 18, where we are going to continue talking about exponent rules. In this video, we're going to look at how to distribute an exponent across multiplication or division, and we're also going to look at combining all the different rules for exponents. So looking at number 13, remember that my bases can be split up by type. So 2 would be considered a separate base from the n. But both of them are getting cubed. So what I can do is I can send this exponent in across that multiplication sign, giving me 2 cubed times n cubed. This is the exponent form. But I could take, because I just have numbers, 2 cubed could be multiplied as 2 times 2 times 2, which is 4 times 2, or 8. So the evaluated form would be 8n cubed. I cannot stress this enough. It is only legal to distribute an exponent across multiplication or division. That's because exponents are just multiplication to begin with. So let's try number 14. I have two different types of bases. I have a -5 and I have an x to the 4th, both getting cubed. So what I want to do is write this first base, this -5, with its cubed. Notice I put it in parentheses. In fact, I could always just keep those parentheses because I need that negative to still be hugged with my 5. My second base already has an x to the 4th, a 4 exponent. Now I'm bringing in a cube. So this is the first time we're going to see two exponent rules in one. Not only did I distribute that exponent, I now have a double exponent to have to deal with. Well, -5 cubed, -5 times -5 times -5 is 25 times -5. When I multiply those, I get -25. So my numbers could be simplified as -125. However, when I look at this second base, notice that my single x has a double exponent, just like we saw in some of our previous examples in video 2. So what I'm going to do is write that x one time and multiply. 4 times 3 is 12. Remember that happens anytime I have this single base, but a double exponent. As we move forward, we have a couple more examples. We are going to start combining more and more of those exponent rules. So looking at 2x squared y whole thing cubed times 5xy. Whew. Remember order of operations says simplify anything inside the parentheses first. Well, that's as combined as I can get. I can't simplify that any. Then I'm going to deal with any exponents. It's in this step that I would take my 2x squared y and distribute that outside exponent in. So I would have 2 cubed times x squared cubed times y cubed. But don't forget that I still have a 5xy tagging along. Before I go any further, this and this could technically be simplified, could be used to look simpler. 2 cubed, as we saw earlier, was 8. X squared cubed is that double exponent, so I'm going to write the x in multiply. 2 times 3 is 6. Then I still have a y cubed being multiplied by a 5, an x, and a y. Once I've sent that exponent in and simplified it, now I'm going to come back and multiply all the different bases, combining them as I go. So this takes us back to where we were in the second video, where I take the things that have the same base or that look alike, like 8 and 5, and combine them. 8 times 5 is 40. Then I can take the next x to the 6th times x. Because those have the same base, but notice it's not a shared base. Look at the difference in this and this. Up here, I had a single letter base x, double exponent that got multiplied. Now I have two separate terms that I write as a single base and add the exponents. Those are two very common rules that get flip-flopped. A shared base, like x squared cubed, is when I multiply the exponent. If it's two separate bases, that is when I add my exponents. Continuing our conversation, I still have a y cubed and a y that I can combine. So since y cubed and y with a 1 exponent are two separate terms, I can write that letter y one time and add up my exponents. 3 plus 1 is 4. And that is the simplified version of this thing. Whew. We are going to continue practicing these rules as we move throughout the next couple of lessons. But for right now, we still have 5 more to go. Remember that I can distribute an exponent across multiplication, but I can also distribute it across a division. So if I have 2/3 whole thing to the 4th exponent, I can rewrite this as 2 to the 4th over 3 to the 4th. This would be in our exponent form. But I could also multiply it out. I could what we call evaluate. 2 times 2 is 4. 2 times 2 is 4. So across the top, I have 16. On bottom, 3 times 3 is 9. The other 3 times 3 is 9, leaving me with 81. Good. All right, we have 4 more examples to go, all of which are going to continue to combine our rules. Don't forget that as we're looking to simplify, there is still an order to that. Everything we're doing is going to have just multiplication or division, exponents going on. There's no addition, subtraction in these lessons. And I'm going to kind of start pushing us to start at the beginning. Is there anything inside of the parentheses that I could combine? The answer for this one is no, because they're all with separate bases. So the next thing I'm going to take care of is any outside exponent. I'm going to distribute it in to each of the different bases. Meaning, on top, the 2 gets cubed, and the a squared gets cubed. On bottom, b to the 4th gets cubed. To simplify that, 2 cubed is 8. Because they have a shared base, that double exponent tells me I should multiply. Write the a one time and multiply. 2 times 3 is 6. On bottom, again, I'm sharing that base of b, so I write the b one time and multiply 4 times 3 is 12. There was no other addition, subtraction, or not addition, any multiplication, division to be able to deal with. Having just seen number 17, I would like you to pause and try 18. Please pause and try 18. Assuming you've done that, there's nothing inside to simplify because each base is different. So my outside exponent would be distributed in to everybody. So -3 with a 4 exponent, that's not -3 times 4, that's -3 with a 4 exponent, times m with a 4 exponent, divided by into the 5th with a 4 exponent. This first one, -3 to the 4th, because that's all just numbers, I could multiply it together. In fact, I believe we saw that earlier. 3 to the 4th is 81. Notice, double negative turns positive, double negative turns positive. When I multiply these together, I still just get 81 into this first spot. M to the 4th, there's no exponents to combine, so it's just m to the 4th. And on bottom, I have that double exponent that is sharing a base. So I write the base one time and multiply. 5 times 4 is 20. Good. Okay. You know that if you're struggling with these, if you have any questions, any concerns, all you have to do is reach out. Let me be there to support you. Now, 19 and 20 are a glimpse of some of what I would call the more intense examples. It's going to have our parentheses, then our exponents, then any multiplication or division. So inside of this parentheses, what I'm looking for in this step is, do I have any bases that I could combine? Well, yes, we do. So go ahead and rewrite your big parentheses in the outside exponent, because that's going to come into play next. Inside of our parentheses, I have an 18 and a divide by 6. Those can be broken up and taken care of separately. 18 divided by 6 is 3. So I could even go ahead and let me bring this down so I don't lose track of where I am. Then my next base, I have, x to the 5th and x to the 4th. That can be, well, sorry y'all, I don't know why my computer's wanting to throw a fit right now. That x to the 5th and x to the 4th can be written as single time, single x, and because of division, I'm going to subtract those exponents, giving me x to the 1. And last but not least, y cubed and a y. Because those have the same base, I can write that base one time and subtract the exponent, giving me y squared. So this has gotten a little messy. Let me kind of pause and rewrite that. So we ended up with, inside the parentheses, 3x to the 1 y squared. Whole thing cubed. Notice that simplifying inside of that parentheses first has now made that inside look a whole lot prettier. Or at least better than it was. Now I move into the second step, which says that outside exponent can distribute in to each of the bases. So I have 3 cubed times x to the 1 cubed times y squared cubed. And when I simplify that, 3 cubed, 3 times 3 times 3 is 27 times x cubed times y to the 6th. Those double exponents multiply together. Why don't you try that exact same setup? Combine everything you can first on example 20. Try it, and then we'll walk our way through it. All right, so looking inside of our parentheses, combining all that crazy stuff first, what I want you to notice is that I've got x's side by side on top. I've got y's side by side on bottom. It will be easier to combine them first before you start looking up and down. So what I mean by that, if I just look across the top, x to the 5th times x squared can be written as a single x and add those exponents. Now that numerator, that hidden parentheses, is as combined as possible. On bottom, I have a 9, an x to the 4th, but I also have some y's side by side that I could combine, leaving me with y. 2 plus 1 is 3, y cubed. So I looked across the top, combined. Look across the bottom, combine. Now I'm going to start looking top and bottom. Everything inside of that parentheses, simplify, combine them first. My numbers can combine, my x's can combine, and my y's can combine. 6 and 9 do not divide nicely, but I could reduce them by 3, giving me 2/3. Times x to the 7th divided by x to the 4th. I write the x one time and subtract. 7 minus 4 is 3. For my y's, I can write my y base one time. And again, because they're being divided, let's subtract. 5 minus 3 is 2 as an exponent. Once I have simplified inside, there's nothing else that can combine. Now everybody gets that outside exponent. 2 gets squared. 3 gets squared. X cubed gets squared. And y squared gets squared. Each of the individual bases. 2 squared is 4 over 3 squared is 9. This has a shared base with that double exponent, so I'm going to multiply, giving me x to the 6th. And last but not least, a shared base. I write it one time and multiply. 2 times 2 is 4. Whew, good job, y'all. We have made it through our first round of exponents. Make sure that you work on your homework. Bring me questions as you have them. If you're still feeling pretty shaky on this, it's okay. We're just starting this process. We will continue practicing for several lessons.